Today's question is, what is time? It's quite a difficult thing to answer really, because we kind of, we have an idea of what time is, but it's very complicated topics. It's a wide area. Let me give you this brief idea. If you're sat in a room, on a chair, there are no doors, no windows, there's no possible way to get out or experience anything outside the room. And inside the room, there's just you on a chair. How on earth do you know when time has passed? Because there's no windows for you to see when the sun goes down and the moon rises. So you can't tell when it's been a day. You can't tell if it's even been an hour, because you don't have a clock or a watch. How do you know that time has really passed? You don't. The only way that you can really tell if time is passing is when something happens. And it happens regularly. We define a day, 24 hours, as a full rotation of the Earth. But if the Earth just stopped moving, does that mean that time stopped as well? Or, well, not really. Obviously, if you did sit in the room, and after a while you managed to get out, you'd find out that so much time had passed. But another thing you can think about is, does time actually pass differently when you're conscious of it? See, when you're actually sat down and you're waiting for something, like if you're in a waiting room and you glance at the time on your watch or a clock on the wall, it seems to pass a lot slower, because not much is really happening. It's just you waiting. So does that mean that when your mind isn't working properly, when it's not working its fastest, that your reality also moves slower? Is that something that we could suggest as a possibility? But there are all sorts of different things that you could say about time. One of the great things about time in physics is that in a lot of it, we only look at the intervals in time. We don't look at definite points. If you're using any of the Suvat equations with motion with constant acceleration, it's all a time interval between when time is 0 and when time is t, let's say. And you just use that interval. It's really quite a simple process. But when you're looking at time in general, it becomes a lot more complicated. And something you can think about is that you can't actually see this video without time, because it's taking time for your computer to download and buffer the video, and it's taking time for the photons to travel from the screen into your eyes. It takes time for you to experience anything. Everything that happens inside the human body, all of your brain's responses to interactions are caused by electrical impulses, and these take time to travel through your body up to your brain, and then for you to react to the situation. Even if you're just sat in a room thinking about something and not doing anything at all, just thinking, that is still going to take time, because the impulses have to travel around your brain. So time is quite a complicated thing really, because it affects us in so many different ways, but we just sort of choose to ignore it a lot. I mean, it's not... Obviously, you notice when a day passes, but you don't spend the entire day counting every second, every microsecond, every nanosecond. You just sort of ignore it, and you let time flow into our reality. It's just something that we do and we take for granted. So hopefully this has got you thinking about some useful things, because another thing you can think about is time changing? Is the rate at which we experience time changing? Because if it does, are there serious repercussions, or does it not matter? There might be an alien life form somewhere up there on a distant planet that just sort of lives in a faster or a slower time than us. Their day might be our year, but they still experience it as a day for them. You know, we as humans have this almost set experience of time, which just varies depending on how busy we are, really. So, hopefully this has got you thinking a bit, and stay tuned for more videos on random concepts and scientific discussions.